So, most of you were here for Dr. Bryan Raney's last Python tutorial, the basic introduction to Python. So today he's going to be taking us through some examples, hopefully some things that will actually be useful for doing research. So I don't think I have anything else to say, so I'll turn it over to Bryan.
Thank you. Okay, so yeah, this is the, what are you doing? Stop running. Silly thing. I don't know why I did that. So this is a continuation of 2 weeks ago. And so the homework was to install Python on your laptops. So anybody have trouble with that, or I guess, who here has a laptop with Python on it is the question. All right, very good. Okay, so one thing, so we're going to go over just examples. Hopefully I won't use the entire time. With my examples, we can get questions and try to figure things out. So, for example, things I'm going to go into: if statements, looping. I'm going to try to show something about gridded data, base map, if I can get it to work, for drawing maps, and whatever else we can come up with. So yes, you have laptops, you have Anaconda. So if you can download that file, you can follow along. You can get my notebook and my data files and put them on your computer, and you can practice with me, because some of the stuff you'll have to have the data files on your computer if you want to do it. So go ahead and type, so it's people.imsci.rutgers.edu/braney, that's me, Brainy, and then python-part2.zip. So I'll wait until everyone's at least started the download. So, and you should also, well, yeah, the Jupyter part we can do once you have the file. So is everybody, yes?
It might be a little while because it's 122 megs.
Is it slow?
Yeah, because of the wireless.
Well, okay.
Mine is only at 3.8 megs.
Just like 4 minutes.
4 minutes? Oops.
3 minutes.
And everybody's trying to do it at the same time. So oops. Didn't realize it was that big. Anybody have a problem finding the file? Anybody not know what to do with the zip file once you download it? It's okay if you don't.
Should we unzip it?
Yeah, unzip it, and then once it's downloaded, you unzip it, and then you open a command prompt and go to the directory where you unzipped it to, so that the notebook is in the current directory, and then there's a data subdirectory under that. I can show you what it looks like for me. So I have a few more files than in the zip, but it's going to be this examples.ipy for the notebook, and then a data directory that has apparently a lot of megabytes of files in it, and then a couple other things. Everybody, how far along is it? Okay, all right, we can be patient. Eat some pie, I guess. So, yes, you download it, you unzip it, and you basically want to start Jupyter in that location. Dang it. Any problems? Or are we just waiting?
I'm still working on item 2 because I wasn't here last night.
Oh, okay. Well, you can.
I think there's a serious lack of bandwidth at the moment.
Well, you can also look on someone else, I guess, if you want. Okay. It's all available. You know, if you don't want to follow along, that's fine. You can just watch, and it'll be on the video, and you can download it later if you want. So. Okay, everybody still downloading? Anyone still downloading? Okay. Unzipping, okay, no problems. All right. So, and then we're going to run the Jupyter Notebook and this, okay, we're done with the slides. So, one thing I forgot to do with the notebook was clear it out. So if you bring up the notebook in Jupyter, you want to go to Cell, All Output, Clear, so that we can start over fresh with just the code. Anybody not in Jupyter yet? Okay. I'll wait a little. I mean, hopefully this won't take too long, so. I guess raise your hand if you have the notebook open in Jupyter. No? Nobody? Okay. What? Yes. You got it. Okay. Anyone else? Keep your hand up if you've got it open. Okay. Anyone want me to wait, or should I just continue? All right, I'm going to just go on. Too much dead air. Okay, so if you clear it, if you go to Cell and All Output Clear, then that resets the notebook, and it hasn't actually run anything yet.
Brian,
And
can you make the font a little larger?
oh, sure. How's that?
Thanks.
Okay. All right, so these first few lines are just loading some of the libraries that we need, the NumPy and the PyPlot stuff. So I have to hit Shift-Enter to make it run, and then it has the little 1 here, which means it's actually done that. So these things are in memory of Python. So I just want to go, because I missed it last time, I didn't talk about if statements, which are kind of important if you're writing any kind of code. So if I have a value that's 1.3, and I want to test if it's greater than 10, this is what the if statement looks like in Python. So basically it's if, and then the thing you're testing, and then a colon, and then you indent, and then whatever you want to do if that's true. So the indentation is important. That tells Python that this line of code goes with the if statement. But if you type something else here, then it's still indented. It's still part of the if statement. But if you remove the indentation and type something else, then that happens regardless of the if statement. So if we run this, it doesn't say windy because 1.3 is not greater than 10, but it does say done. Okay, so if we change this number to 10.3 and run it, then it says the windy statement and it says done. Any questions on that?
Can you also do an if, else?
Of course, that's the next step.
So you have to do the indentation by pressing tab.
Well, you can do tab or spaces. If you're writing code in a text editor, the important thing is that you're consistent. So if you hit tab here, then for each line that goes in that if, you have to also hit tab.
I was just wondering if this could be sensible to the sort of like editor I'm trying to use.
Well, yeah, so a lot of editors are intelligent. They know what they do it for you. Like in Jupyter here, it indented for me. So I'll show you that here. So
just by virtue of having if on the line.
the colon tells it that the next line is probably indented, but it's it's up to you to make sure the indentation is correct. Okay? So let's say we want to have it print something if it's not windy. So then you say print not so windy. But it still says windy because 10.3 is still greater than 10. So if I change that back to 1.3, now it says not so windy. You can even stack these up. And that's elif. And so then you can say something like that. So now you can have as many elifs as you want, and then you'll have all these different conditions that you're testing for. So this is basically saying, if the value is greater than 10, do this. If it's less than 1, if it's not greater than 10, but it's less than 1, then do this. If it's not greater than 10, it's not less than 1, then you come to the else, which is the catch-all. You don't have to have the else, but usually you will. Okay, and so now if I pick a number that's less than 1, then it writes calm here. And so this will, I mean, you're not always going to be printing words, in this case. You'll be doing something. But for illustration, and you can have multiple lines here. So you can, you could say W equals W plus 1, like if you were counting the number of windy days, something like that. But then you'd have to have W equals 0, C equals 0. So you can have multiple lines underneath the if as long as they're all indented. Any questions about that? Is everybody running the notebook?
No, I missed the part that got you running Jupyter.
Oh, sorry. Let's bring that up. Come on now. Where is it? What you want to do is you go to the directory. Whoops, dang it.
Oh, okay. Notebook example.
Just say,
Got it.
yeah, Jupyter space, notebook space, and then the notebook file. Anybody else having issues? All right, that's pretty good. Okay, so we have if statements, and feel free to play around. This is a notebook. You're not going to break anything. You can just do whatever you want in these cells. You can add your own cells and try things. I'm going to move on to looping. So there's all kinds of different ways to do looping. And typically you want to do looping when you want to accomplish the same task on several different pieces of information. So the very basic version of that is, let's say you have a list of numbers, and you want to loop through each number and do something with it. So in this case, let's keep it simple here. Let's just print value. So what this does is I give it a list of numbers, and then I say for, and then I give a name. This name is just part of the loop. This is the thing that is changing as we loop through the list. And then I say in, and then the list of things to loop over. So if you're used to other programming languages that have a more cumbersome for loop style, where you have to worry about indexing and stuff like that, you don't have to do that here. It's pretty much just, I want to loop through the items in this container. And so what it does is for each one of those items, it will print the value. And so you can see it prints 4 things because there were 4 things in the list. Any questions about that?
But what if you do, suppose you were looping through like latitude and longitude, so you wanted to have two indices?
Okay, that depends. So if you, in this case, I'm showing a very simple Python list. In that case, you'd be using the NumPy array. And so there'd be a slightly different mechanism, but I can show that in a minute. That's a good question. So now I can change what I'm doing here. I can multiply by 3, which then, instead of showing the individual items in the list, it shows some sort of transformation of them. And let's do +2, because that's my examples below. So this is the basic for loop. Notice there's a colon at the end, and the print statement is indented. So it's the same rules as before. You can do multiple things. So you could say a equals value +2. So you could have multiple lines here, and they all happen each time through the loop. Okay?
Right.
Yes?
If you wanted to run just like the second and third element of value, how
Second and third, so the 5 and the 21? Okay. So because the indexing starts at 0, so the 5 is actually index 1. So I put a 1 here, and then I want to go to 2, but you actually have to put the 1 after, so it's 3. So if we do that, it does the 5 and the 21, but it's adding 2 to them.
So, Brian, the things that are indented, the 2 lines that are indented are part of the for loop.
Right.
It knows that the for loop has ended when it encounters something that's not indented?
Right. Yes, that's typical of Python. So, in other languages, like in Fortran or something, or MATLAB, you'll have like the word end or something to signify the end of the loop or the end of the if statement. But in Python, it relies on the indentation for that. So in other programming languages, indentation is optional and highly recommended. In Python, it's required.
And indentation can be with spaces or tabs
It-
or
It's up to you.
anything?
There's no required amount of indentation or style of indentation as long as each line is consistent. So, yes, Matt.
I did for value and values, space 1:3, space colon.
It's not spaces, those are square brackets. They're just hard to see.
Oh,
Sorry, it was highlighting them because of where my cursor was.
I couldn't see them.
Yeah, it's square brackets. So the square brackets are saying, I want to look up something inside the values list.
But if you wanted to nest a for loop in another for loop, is there another set of indentations?
Yes, yes. So you could, yeah, okay, let's try that. Let's insert a cell below, and let's do values 2D equals. So this would be for row in values 2D, for call, or I guess for val in row. So that is looping. So this here is a list of lists, which I don't really recommend using too much. The NumPy stuff is better, but what this first one is looping through the outer list, and then the second loop is looping, taking the outer list as its input, and then looping through that list. So it's sort of staged. And then, so I'm printing the value each time. So this is just going through the whole thing. Now I could do other stuff, like I could say, and then you can see like it does the equal signs once per row, and so you can do all kinds of stuff like that. And you can see from the indentation that this print goes with this for loop and not this one. So, any questions about that? Okay. All right, so Now, if you wanted to, like going back to this example, if you wanted to loop through the values, get a new number for each one and store that, you'd have to do something like this, at least as far as we know so far. So in this case, I've created a new empty list, and I'm looping through the values list, and then for each value, I'm appending to the new list the new value. And then I'm printing out the new list. So you can see I've got a list here, as opposed to up here, where it just printed each thing, but it didn't store them anywhere. Here I've actually stored the list in a variable. But this is a lot of, it's very wordy, and Python doesn't like that. So there's a better way to do that. So if you go down here, this is the same exact thing. So what this does is you say this variable equals square brackets, and then you're actually doing the for loop in the square brackets, essentially. So you're saying for v in values, and then, but the thing that goes before the word for is what you want to stick in the resulting list. So if you think about it, it's taking this, you have to kind of read it from right to left. You take this list, you loop through it with the value v each time, and then you calculate v plus 2 each time, and then because that's in square brackets, you store that as a list. So this is doing the same thing as this loop up here. It's just a more compact way of saying it.
And on line 16 there, you do have to define the variable before.
Right, in this case, yeah, because otherwise if you said dot append and it wasn't defined, it wouldn't know what you were talking about. So what this does is this produces a resulting list first, and then it stores it in the variable that you name it. So you don't have to predefine it. I have to show you this because you'll see it a lot in other people's code, and it's pretty useful. Any other questions so far? All right, so another thing you can do, let's say you have a function, and here's how you define a function. It's pretty much, it's pretty similar to what we've seen already. You've got def, which means define, and then the name of the function, and then the inputs of the function, and then a colon, and then all the indented lines after that are part of the function definition. So what I'm saying here is I send it something called old value, and then it calculates a new value based on the old value, and then it returns the new value. So if I have a value of 50 and I call that function, store it, and then look at the output, then the result is 50 plus 2. So what you can do then is you can take this idea up here, combine it with the function, and you get this, where you say, for all the v's in values, call the function on the v's, and then store the results. So that results in the same list as the other ways.
This might have been something we covered last time, but for the def, does Python understand, I mean, is that specific to defining a function?
Yeah, well, pretty much, yeah. So def just means I'm defining a function. There are other things you can define in Python that use other words there. So, and then, so this is a slightly more advanced idea here. So here, well, okay, we gotta look at this closely. When I write this here, I'm calling the function called compute new value, and I'm giving it a value. So I'm giving it information, it's running, and it's giving me an output. Here, it looks like I'm calling compute new value on the value of v, but I'm not really, because this is sort of symbolic. What I'm saying is for all the v in values, I'm going to be doing this with each one of those v's. So this is, instead of calling the function, this is sort of like a description of that you're telling Python you want it to call the function. So the automatic looping that happens with the for here is calling the function for you. So even though this looks very similar to this, they're slightly different meanings. And here is another way of looking at it, where I'm calling a function called map, and I'm giving it, instead of calling the function compute new value, I am passing the function into map. So I'm telling map, hey, use this function. And then I'm giving it the list of values. And actually, if I run this, this doesn't work. It says, I have a map. What you actually have to do is put list around it to convert the map to a list. But so what this does is, for each value and value, it calls the function on the value, on that value. So it's exactly the same as this. It's just another way to write it.
So it's not any more efficient?
It could be. There's actually similar functions in the NumPy that are more efficient than looping yourself. But this one's a little easier to comprehend, so I'm showing that first. So, does that make any sense? Like, so here's values, there's values. Here's compute new value, there's compute new value. It's just that the v and the for v part are handled by map. And the reason you have to put list here is because map returns something called an iterator, which is like actually when you do the for loop up here and you put values there, Python converts that list into an iterator. And an iterator is a thing that you use to go through lists. But the trick is that you don't have to have the entire list in your memory. The iterator can figure out what the next value is every time you ask it. So it's good for loops because you don't have to remember everything, you just have to know where to look. It's mostly a thing that happens under the hood, but it is a concept that Python programming encounters. So for example, you can use the map thing directly into a for loop. So that would be, so instead of storing this in a variable and putting that variable here, I just put the map directly. And what that allows me to do is go through the list that the map would produce without actually storing the entire list. So with the for loop sees the map as an iterator and it tells it, okay, give me the first item in the list, then give me the second one, then give me the third one, and it keeps doing that until map says that there are no more. And so this is much more efficient typically than doing this first and then doing, like if you were to write for, what is going on here? So you could write that as doing the same exact thing. So you would be looping over the list that you made up here, but this version is more efficient. So just two different ways of doing it. All right, now for the next level of advancement. Are there any questions so far? Okay, I mean, you don't necessarily have to follow all this just yet, but these are concepts that I think are very useful, and we can talk more in depth about them if people are interested later. So the lambda is a way of defining a function without defining a function. So here, like, if we compare this up here, so I'm going to copy this down just for reference. So before I gave it the name of a function, and then it would call that function inside the map loop. And here, instead, I'm defining a function on the fly. So I say lambda is that's just a fancy computer science word. What I'm saying is I have a variable v that is my input, and then the output is v plus 2. And so what this entire thing does is Python generates a function for me that has that input and that output. And then it gives that function to the map thing. So it's a way of, it basically removes the overhead of having to write all this stuff in the situations where that makes sense. Sometimes you do want to have a function and you want to call it, but sometimes if it's a quick and dirty thing that you're doing, then a lambda is easier to see what's going on. Because you can see v is turning into v plus 2, and that's all you need to know.
So if you had a function that involved like a two-step transformation, could you use this lambda syntax to do that? Like suppose you wanted to first add 2 to v and then do
times
something
3.
else to it,
Yeah.
which you'd represent in the other form as a line
Right.
break.
You can do that, but once you start getting a lot of that, then the lambda doesn't make sense. Lambdas are meant more for pretty terse things. So you might like, and it's very contextual. So like if for some reason I was expecting v to be a list, then I might have to do something like v is 0. So it just depends. So if you have something complicated, then you should put it in a function. But the lambdas are typically for something that's just pretty short and to the point. But I think you can actually, I think there's a way to append multiple statements there, but I haven't looked into that, so I'm not sure. Anyway, let's comment this out and then run this. So this is doing the same thing as before. It's producing the same list. And then, so you can actually take a lambda and store it in a variable, and then that variable becomes a function. So like here, I've defined my lambda. It takes 2 inputs, an x and a y, and then it produces this output, which is just some equation involving x and y. And then if I store that into the variable func, and I call func with 3 and 4, it returns that output of 5, which is, and if you wanted to write all that out in a more explicit way, then you would do it as a function. And so this function is functionally the same as this lambda. It's just 2 different ways of doing things. So anyway, any questions on that or confusions, or why did you go over this? Questions?
It's hard to see how useful lambda could be instead of just using function.
Yeah, I mean, you don't need to use lambda. It's completely optional. But there will be situations where, one of the reasons I'm going over these things is because you're going to see them in other people's code. So you need to have some idea what they mean. In terms of using it yourself, you don't have to use it until you're ready. But you'll be ready when you realize, dang, I have to write all these little functions all over the place, and I'm only using them in one spot, and it would be nice if I didn't have to, do that extra work. So the lambda takes care of that for you.
Well, that seems like it would be very useful, for example, if you have to do sort of unit conversions. You have
right.
precipitation in one set of units, but you want them in another set.
Right, exactly. So, yeah, these are just things I think you should have some idea what they are. Any other questions? Wow, it's already 1:12. Okay, let's move on. So this is going to be a little different. This was supposed to be not doing that. Yeah, okay. So I'm going to, this is a little bit of a diversion because we're going to need this later. But one thing you sometimes need to do in Python is call another program. You know, that other program could be very simple, like a little utility, or it could be you're running a model and you know, Python is managing the running of that. But basically, there's a few ways to do that. There's a module called subprocess, and if you load that and do call, and then you give it a list, and the list is the first item in the list is the command you want to run, and then everything else after that is the arguments to that command. So if you were typing this on the command line, it would look like open that, for example. So if I ran that on the command line, it would open this file here. And okay, great. So then if I do it in Python, oops, it's the same thing. So if I run this, it does the same exact thing. It's just written in a slightly different way. And then if you want to actually see the output of that program, then you would use check output. And then it runs this program. That program does some stuff, spits out some output. The output is stored here, and then you can do something with it. And then if you're in Jupyter, you can do all that more easily with the exclamation point command. So you say exclamation point and then the command you want to run, and it does that.
In 29,
Uh-huh.
where did the B and the slash end?
Okay, so the echo command prints the line with the return character after it. So the backslash in is the return character. And then the B and the quotes mean this is what Python calls a byte string. So it's basically a list of characters. Python hasn't quite converted this into its own string type, basically. It's sort of like, it's just, because this is coming from another program, it's not in a nice format. In this case, Jupyter is doing some extra processing to make everything smooth. If I were to, so usually when you're processing something like this, you'd say like, whoops, output.trim, I think it is. Whoops. Oh, it's a bytes object. Well, let's try this. Output equals. And then what is it? I forget the command. Trim, what is it? It's not trim, it's something else. There's a command that strips off the extra characters, but I can't remember what it is. Oh well. Let's see if I can. Python, whoops.
I think it's strip.
Strip, okay. Thank you. Where did that go? Yeah, trim, I think, is Perl. Well, that didn't work. That got worse. All right, well, I don't know what to do here. I could figure it out, but that would take too long. Weird. Oh well. Anyway, so that's running an external program, which I will be doing in a second. But first, I have to explain The next part I want to cover is gridded data, which is very common in the atmospheric science and the ocean science when you have like model output or like reanalysis, anything that comes from a nice computer model that can give you regular information. So for that, I'm going to show this picture. So let's do that. Yeah. So if you have, let's say you have data on a latitude, longitude grid. You've got, over here you've got the two-dimensional grid of information, and then each row has an, that should have started at 0, whoops. Each row has its own index, and each column has its own index. And then you also have associated with those rows and columns latitudes and longitudes. So that longitude is a separate piece of information from the actual numerical data on the grid. And same with the latitude. So you kind of have to associate the two in order to use this information. And then, but the number of rows in your data matches the number of latitudes that you have. And the number of columns matches the number of longitudes. So it's a nice regular format, but you have to deal with all three of them. And then that gets more complicated when you have the time axis. So here's your nice two-dimensional grid for time, the first time index, and then you have a third dimension going backwards of each additional time index has another grid of data associated with it. And so in that case, you have a third coordinate, which is your time dimension going back there. When you have data like this, there's a lot of separate pieces of information that have to go together. Typically, this is put into what's called a netCDF file, which is a particular format that stores the grid and the coordinates and all kinds of other metadata, which is data about the data, so that you can use it correctly. Who here is familiar with netCDF in some way? Okay. So I'll show that a little bit. So the first thing I'm going to do, I've got a netCDF file. That's probably the main reason the zip file was so big. I'm going to run this program called ncdump, which shows some information about that netCDF file. So it tells me, here are the dimensions. So these are the three coordinates in the file. So it has a time coordinate, a latitude, and a longitude coordinate. And then these numbers here, it's saying there are 361 latitudes in the grid, and there are 540 longitudes in the grid. And unlimited just means the time axis is allowed to grow. Right now there's 248 time coordinates in the file. So if you look down here, then these are variables now below here. And so the latitude variable is indexed on the latitude dimension, which means there are 361 actual latitude values. So it distinguishes between dimensions and variables, but they're usually named the same in the case of coordinates. So this is giving you things like units. It's in degrees north, and it's called latitude and stuff like that. So there's a longitude and a time as well. Now time is always interesting because it doesn't store year, month, day, hour, minute, second. It stores it in this case, number of days since this particular moment. So if it has the value 1 for time, that means 1 day after January 1st, 1900. If it has the value, see, this is kind of giving you more information, telling you the minimum and maximum numbers, which is telling you, 41,000 days after 1900. So that's some number of years. And then up here is the real variable that we're interested in. This is the air temperature variable. And you can see it has indexes along all 3 dimensions. So it is that 3-dimensional grid with the latitude, longitude, and time going back. Yes?
I keep getting the error NC dump not found.
That's because you don't have it installed on your computer. Sorry. It's an external program. It's not part of Python. I didn't think about that. I thought it came with the Python stuff, but maybe not. But there are other ways to get this information with Python. This was just the quickest way that I knew to get it. Did you install the netCDF package? Okay, because that was in my instructions. I had mentioned that you could install that. That's probably why you don't have it. You'd have to install that using the conda command. And you can just try it right now. Conda install netCDF 4. And that should bring the nc dump command with it. But so you get here that the units of T-air are Celsius, and it has information about like fill value and missing value. That's not terribly important to us because the netCDF commands deal with that themselves. Anyway, so this whole thing is basically designed to define this one variable, plus all the coordinates that go with it. Yes?
Brian, since I'm playing catch-up,
Mm-hmm.
what do I have to do to get this file in my...
Oh, yeah, let me see here. So after you install the Anaconda,
That's done. I did all of that.
did you do that?
Yep.
Do you mean the notebook?
Yeah, I want the notebook.
Oh, sorry.
Thank you, Brian.
Hang on. For that, you want to go into the directory where you unzipped the data file and just call Jupyter Notebook.
Okay, I probably don't have the data files.
Oh, you didn't?
That's the
Oh,
line.
Yeah,
so,
okay.
so go here and download this zip file. And then when you downloaded it, unzip it, which in Windows should be, I think you can right click on it and unzip it, or what is the word? Expand it or something like that. Or extract, that's the word, extract it. And then,
So you were saying with the particular data we were looking at for T-air,
mhm.
it had, some 10 to the 15th or something specified as a missing.
Yeah, I guess I should explain that. So the the file basically just stores a bunch of numbers, plus this information that's shown here. So what they typically do, there are cases where when you have data, you have cells in the data where you don't actually have data. But because this is all designed to be a regularly spaced data grid, you have to have something there. And so they pick a value that lies outside of the normal range of numbers and use that to indicate there's actually not data here. This is what they call the missing value. So when, if you were doing something, I mean, most programs that read netCDF files will handle that for you. But if you were doing it in a very low-level way, you'd have to look for that value yourself and somehow mark or recognize that that's actually invalid information.
So I think you answered the question, but Python knows how to deal with.
Yeah, the netCDF 4 module will deal with that. So that'll be part of it. Let's see. So they use fill value and missing value because different programs look for different names for that. But it's just the number that means invalid in this particular situation. Different files might use different numbers for that.
But that's so that whatever, when you read the file,
Mm-hmm.
you don't have to stick to a predetermined value of what represents missing, because that
Right.
may be dependent on what the data is supposed to look like.
Exactly. If your data actually took on values close to one to the,
You wouldn't
you
want
know,
to use those.
exactly, you would want to use some other crazy number. So usually I think these numbers are chosen automatically when the file was saved, but it depends on who created the file and stuff. Okay, so any questions so far about what I'm talking about or what I'm doing? Yes?
I keep getting DLL load errors whenever I installed netCDF 4, but I don't get
What operating system do you have?
Windows 10.
I don't know.
So I had that problem when I was installing just an hour ago Anaconda,
Okay,
when I tried to install the 64-bit version.
really?
But then when I switched to the 32-bit version, it worked.
You could try that. DLLs are the way that Windows handles dynamic code, and it's when you have a DLL error, that's usually a pain to deal with. In general, it means something went wrong probably during the installation, or when you told Conda to install something, maybe that didn't work. It depends on which DLL it's complaining about and stuff. So since it's Windows, the usual answer is to, do something drastic like uninstall it and reinstall it or something like that. But the 32-bit might be a good workaround.
You probably had Conda installed already, right?
Yeah, I had it for a while.
Yeah, so we may just be generic DLL and
So when did it give you that error?
Whenever I tried to, when I called NCDump, or when I tried the next line, which was using netCDF 4, it won't do that either. So maybe something happened when I tried installing netCDF 4
When did you install netCDF 4?
half hour ago.
Was it before or after you opened the notebook?
Oh.
If you did it after you opened the notebook, then the notebook is using a version of Python before you installed
I
netCDF.
feel like it closed it and reopened it. Let me try.
You could reset the kernel,
Yeah.
restart your kernel. That might help. But I can't take time to debug that right now. It's a Windows painful thing. Okay, so. Well, I'm sorry that some people are having issues with this. If you have major problems, you could always put Anaconda on like a server, like a Linux server that doesn't have the Windows things, or we can sit down and work on it later, offline. Any other questions at this point? All right, so now I'm going to use the netCDF library, or module, and I'm going to point it to the same data file that I did the NCDump with. Oh, and this is the with statement, which I didn't cover yet. So with the netCDF thing, what you have to do, the library does not load the entire contents of the file into memory when you open it. This is good because you can open very, very large files, and you might only be interested in a subset of the data in that file. So what you have to do is you have to open the file, do some stuff with the file, basically extract the parts you want, and then close the file. And closing the file is very important, but it's often forgotten. So what Python did is they came up with this with statement, and that basically is like an automatic open close. So what we're doing is we're saying with this thing, that's the command to open the file, and by saying as ds, I'm giving a name to the open file so I can use it. And what happens is when the indentation stops, then the close happens automatically. So it's just nice. And it's indented because there's a colon there, and it just is a visual indication that what you're doing there relies on something that is temporary. So the ds here is a temporary existence as long as I'm in the with. Once I'm done with the with, ds is not valid anymore.
So that syntax in the parentheses, the R.
Okay, so this is particular to the way netCDF works. But yeah, it's saying, here's the file I want to open, and R means I'm opening it to read it. You can also use a W to say I want to write to it. And then you would be doing very different things. You would actually be taking data that you already have in variables and sticking it in the file and stuff like that. Writing to a netCDF is a whole nother talk, probably. But reading from it is not too bad. So I'm saying, basically, open this file for reading, call it ds while it's open, and we're going to do some stuff with ds. So first, ds, so if you look up here, you've got dimensions and variables, and then I'm actually saying ds.variables. So it's very similar to this layout up here. And then I'm saying the name of the variable I want to look up, which matches this name here. And then, so that whole thing, ds.variables tair, refers to the entire concept of that variable, not just the data. So like I can say long name, I could say, whoops, dang it. I can say I want to see the units, whatever. And then if you put these, so here I'm doing the same thing with the long variable. If you put the bracket, colon, bracket there, that means take all of the data from that variable and store it in here. Excuse me. And then do the same thing with latitude after that.
So the with command is more like creating a link to the file rather than loading on the computer?
The with doesn't do that. The NC4 does that. The NC4 is essentially opening that file and looking inside of it. And then when you do these types of statements, then you're telling the NC4 to do things with the file. So essentially, what this line is doing is it's shuttling information out of the file into memory. That information was not brought into memory until we asked for it, because you may not want all of it. So for example, instead of saying colon, I could say, I just want longitudes 0 through 9. And then that way I get a subset of the data instead of everything.
Right. If you just wanted to go ahead and load the entire file with all the variables, what would you do there?
Well, you'd have to have one of these lines for each variable. You'd have to specifically ask for each one. Here I'm grabbing tair, but not all of it. So you can see here I have 3 different things in the square brackets because there are 3 dimensions to this. So time is first, then lat, then lon. So what I'm saying down here is I want the 100th time slice, and then I want all the latitudes and all the longitudes. So I'm right there pulling out a subset of the data.
To follow up on the question that was just asked.
Uh-huh.
So there's no way to kind of open the netCDF file within Python and sort of look at that point what's in the net?
Yeah. You can do this.
So that'll tell you everything.
Yeah, so you can look through the file yourself if you don't know what's in there. But it is not trivial to try to write code that can deal with any file you give it. You're pretty much going to be writing code either for that specific file or for a family of related files that are all the same format. But yeah, you can browse through that data if you want to.
I guess there I was thinking about my ferret sort of
Right.
understanding, which I open a netCDF file and all of those variables are then
Well,
read in.
actually, they're not read in. It's the same thing as here. They are looked at, but the data actually isn't brought into Ferret until you actually use them for something. But Ferret is handling that behind your back so that you don't have to worry about it. With Python, you have to be a little more explicit. But it's very similar. So like where I ask it to print ds.variables, it's printing all this information, but it's not printing the actual numbers. It's just printing stuff it knows about the data. That's exactly what happens when you say show data in Ferret. It's the same thing, just it's formatted differently. Anything? Yes?
And instead of getting all of that, all it gave me was temperature at 2M above the displacement height. That's all it said.
Well, I changed this code here. So feel free to, because the original code in the notebook just had the name that it printed. So if you look, I'm printing ds variables tair name or long name, ds variables tair units. So all those things are output here. Like here's what you have, temperature at 2 meters above the displacement height. That's the long name, and then Celsius is the units. So all these things I can do and play around with, and then once I'm done with the width, then ds vaporizes, and if I try to do something with ds, let's comment this one out, then it says, oh, no, not a valid ID. So it's saying that's not open anymore, essentially. So we don't do that outside of the width. Okay, so, and I'm typing the type of lawn so we can see that this is actually giving us a NumPy array, which is very useful because it's a lot easier to deal with than regular lists. And if we did tair.shape, we can see tair is 361 by 540, which matches the number of latitudes by the number of longitudes. But we also know that tair, the original, was also 248 time slices, but we extracted only one of them. And so that's why the shape is two-dimensional instead of three-dimensional. Okay? And then if we look at the shape of latitude, it's one-dimensional of length 361. Any questions? So that should remind you of this picture. So before we had three-dimensional data, and we took a two-dimensional slice out of it. So we have this two-dimensional data, the tair, and then we have our latitudes. So the size of the latitude matches the number of rows, and the size of the longitude matches the number of columns. Let's confirm that. So you can see here, latitude matches the first one, longitude matches the second one. Okay? Any questions? Okay. What time is it? Can't tell. 1:41. Okay. 20 minutes. That's pretty good. All right. So let's see. What I wanted to do was, okay. So here I'm creating indices into the latitude array. So I know that the latitude goes up to 361. So here well, this variable is just a list of numbers from 200 to 280. In fact, let's split this up a little bit. So let's start with this and just take a look at that. So that is, so the np.arange function gives us a list of numbers from A to B, but you can see that it actually doesn't include the last one, just like the range function in Python. This is just a normal Python way of doing things. It does start,
By default, that automatically iterates by 1.
yes. If I didn't want it to iterate by 1, I could tell it like this. So it's the starting value, a little bit after the stopping value, and the interval. But let's go back to 1. In fact, I'll just change that to a 1. And then we'll do the same thing here. That's 400 to 500, except it's really 400 to 499, because it never does the last one.
So what, I'm maybe just a little lost here. How does it know what it's acting on, the MP range?
This is just a normal function, arange inside of the NP library or module. And so I'm just giving it some inputs, and it's producing an output. So there's nothing else happening.
I see.
There's no connection to what I was doing above yet.
So these are just numbers that have been generated by this command?
Yeah.
Okay.
So I'm just saying,
Now I understand.
I'm arbitrarily creating a list of numbers right
Now I
now.
understand.
So then what I can do is I can say, instead of printing out the numbers, I can print out the latitudes at those numbers. So now I'm dealing with, this is the 200th latitude in the latitude list, and it goes through the 279th latitude in the latitude list. And then if I do the same thing here, this is the 400 through 500th longitudes. And you can see here that the longitudes are spaced by 2/3 of a degree, it looks like. All right, so then what I would like to do is then take those same ranges and extract a subset of the T-air data that goes with them. If I did it, let's do edit, split cell. So if I did it like this, whoops, those are the wrong numbers, 200 to 280. So if I did it like that, it would work fine, but I want to reuse these numbers up here, and that doesn't actually work. What was it? Lat end, long end. That gives me an error. And if you're familiar with MATLAB, you might have a clue what that is about. And the solution is to use Meshgrid. So when you have a two-dimensional array and you want to look up stuff from the two-dimensional array, you have to have two-dimensional indices. But what I'm trying to give it here is two one-dimensional indices. Instead, I need to give it two two-dimensional indices so it knows which row and which column in every case. So in that case, you use the Meshgrid function. So you take the two sets of indices and you create a new set of indices. So let's split that out. And let's look at, so lat end was the numbers 200 to 279, but mlat is the numbers from 200 to 279 repeated 100 times. So it's now two-dimensional. And then if we look at insert below and long. So what you can see if you look closely is that mlat goes from 200 to 279 horizontally and then repeats vertically, whereas mln goes from 400 to 499 vertically and repeats horizontally. So it's like, if you look at the I comma jth location in mlat and combine that with the I comma jth location in mln, you get a unique pair of coordinates. So now I can put those into my t-air and look up, hang on, let's split that out. So now I've got that. So this is now an array. Actually, let's look at the shape. So we can see that this is 100 by 80. So we've now taken wait, is that right? So the lat indices it went 400 to 500. So there's the lawn ones, there's 100 lawns and there's 80 lats. And this is showing, where did we go? Yeah, here is 100 by 80. Although that feels backwards to me. I'm not sure. This was originally 361 by 540. Yeah, it's gotten mixed up.
Is that because you have the mesh grid?
I probably have the mesh grid wrong. Oh. That's wrong too, though. Lawn should go to 540. There we go. Apparently I had the directionality wrong. Let's try that again. There. Maybe why some other things didn't work. So I did, subset A was actually inputting these things directly, the ranges directly, and subset B was using the mesh grid. And I'm trying here to compare the two, and you can see that the shapes are the same, and it has a big list of trues because it's comparing each item to each other item. Are they equal? That's what the two equal signs means. If I say all, then I'm saying, okay. So if I say, does subset A equals subset B, and then I say all to mean, are they all true? So this gives me true to say, yes, they're equal. They're the same. All right, does that make sense? Any questions?
I'm not sure if I got, can you go up a little bit?
Uh-huh. Which part?
Yeah, so the subset A,
Mm-hmm.
so you give a list of numbers from 200 to 280 and from 400 to 500, right?
Right.
And then on the following line, which would be subset B, you're creating indexes, which is last int and long int. And if these are the same numbers, I don't understand why it doesn't work.
They are the same numbers, so conceptually it should work. But the problem is writing numbers with a colon in it is different from inputting an array. It's treated different by Python and also NumPy. So when when you give it arrays instead of ranges, it treats those as, this is the list of things I want to pull out. It doesn't treat it as a range, it treats it as a list. And so since you're giving it two lists, then each list is for a different coordinate. But since the shape of the array is two-dimensional, then the coordinates lists need to be two-dimensional. So in this case, this is a shortcut for saying I want rows 200 to 280 and columns 400 to 500. But this form,
Just give you indexes.
right, in the second form, even though to our mind it looks like the same idea, to Python it has a different purpose. Because you can do other things with this. Like if you have a list of true-false values, just like in MATLAB, you can stick that in there and it'll give you all the values that correspond to the indices at the true items in the list. So this is more versatile, so you have to be more explicit, essentially. So the whole Meshgrid thing is to illustrate the right way to do that. And if you do this in MATLAB, it's the same problem.
You can give an array of numbers as indexes. to address.
But if you have a two-dimensional array and you give it two different arrays that are not the same size, it's not going to like that, I don't think. But, well, maybe not, but this is how Python, or this is how NumPy requires it. So, okay, so not much time left. I'm going to skip over this one for a second because I didn't get it to work. One thing that's cool, though, there's this other module called X-ray, and it's a wrapper around the netCDF 4 module. And what it does is this whole thing I was talking about with the indices, like you have to use the indices both for the latitudes and the data, right? Well, X-ray takes that away. It takes that requirement away. You can actually tell, so here I'm doing a with X-ray open data set. I'm giving it the name of the data set. It's very similar to the with for the netCDF. And I'm saying ds.tair. So instead of saying ds variables tair, I'm just directly saying tair. And I want to select, and then I can actually give it latitudes and longitudes I want to select on. So if you know ferret, this is how ferret works. You can say, I want to deal with things in coordinates, not in indices. And so X-ray lets you do that. So if I do this, this is, since I'm giving it a single latitude, a single longitude, and a single time coordinate, then it's giving me a single value back. It's pulling that one value out of the entire three-dimensional tair list. Yes?
Do they have to be exact latitude and longitudes?
I don't think so, but I haven't played around with this a whole lot. So this is mainly just to let you know it's out there and you might want to try it.
Could you give it a range?
Yeah, there's a way to give it ranges and stuff. The syntax is a little funny. But yeah, essentially the same kinds of ideas you can do in ferret, in terms of selecting information through coordinates, you can do with X-ray. It was designed that way.
So does that mean you can you could kind of use this as a shortcut for doing?
Yeah, exactly. But you kind of need to know sort of both sides because you need to understand, when things go wrong, you need to understand why.
Yeah.
So, but yeah, if I had more time to play with this, I could have probably done the exact same example with X-ray. But now the base map thing, I couldn't get it to work. What I can do is show what base map is supposed to do. So, like with base map, you can create projections and draw your data on those projections. So like the PyPlot functions, they can do things like contouring and filled contours and stuff like that. What the base map does, and in fact I should enlarge this. So what I'm looking at is matplotlib.org/basemap. So basemap is this module that lets you do this stuff. So it basically lets you project your data onto an actual globe in this case, or other projections. I really wanted to show you exactly how to do this, but I was having some trouble with my data. There's a crazy one. But anyway, so this would be what you would do along the same lines as ferret, like fill and contour and stuff like that. But you can use different projections and do different things with it. I can try to get that to where I can send it to everyone once I have it working, but it's pretty cool. But as you can see, there's a lot of lines of code necessary to do these because you have to be real specific about what your projection is and what you exactly want it to do. But once you have it figured out once, then it's probably easier to do it again. Oh, this is neat. This is like specific points on the map. And I think they're even different size dots. That's pretty nice. Anyway, so the base map is what you want to do if you want to map your 2D data.
Is there a way of kind of turning that into a function? So that
Absolutely. Yes. You could definitely start to write a function that where you give it a netCDF file, tell it a variable you want it to look at. It could pull out the latitudes and longitudes, make a map out of it, and plot it, and do a lot of this stuff semi-automatically. But you'd have to write that code. There's probably somebody out there who's already written that code. But I mean,
Write a lot of it, you've got ferret, right?
yeah, basically. Well, there actually is a Python wrapper for ferret, where you can actually use ferret within Python. But I think it's also useful to know how to do it natively in Python as well. Because I think the reason you would want to use Python is so you have more control. And once you hit the limits of what ferret can do, then you have to leave ferret completely in order to do the next thing. So you might as well not rely on that. But that could be a bridge. You could have some ferret code that you bring into your Python through PyFerret, and then figure out how to translate it back into base map and X-ray and everything else. Let me quickly show one other thing. The Pandas library is for reading column data. And let me show you what I'm talking about. So if I have, let's say I have a spreadsheet, and this is not Excel, but it's good enough for demo. Let's say I have a spreadsheet with a bunch of data in it, and then I save it as a CSV, comma separated values format. Then I can read that CSV file using Pandas. Oh, whoops, I have to do this first, and then do this. And then look at that. It's a nice table showing all the data. So Pandas recognizes the numerical data, and you can, this is sort of like a spreadsheet, but also sort of like a database. You can do searches and find the data that is interesting. It's very different from netCDF. netCDF is meant for sort of uniform grids of numerical data. This is meant for where you have columns, where each column has a different meaning and purpose. And so you can, for example, you can, so here I'm extracting out a particular column, and I'm just using the column header name to do that. And then let's take this off first. So this is actually a particular data format of Pandas that stores the numbers and some other information. But if I put the .get values on the end, then now it becomes a regular NumPy array. So I've got the number. I've pulled the numbers out of a spreadsheet basically, in like 3 lines of code.
So what was it reading in this case?
It was reading the CSV file that was saved from this spreadsheet. So this is an Excel spreadsheet, and then you go into, I don't actually have Excel, but you can do the equivalent. You would export it as CSV or whatever. Anyway, you save it as a CSV file instead of an XLS file. And then when you go here, you just say read pandas.read CSV, and then it does. And you can give it lots of information about your CSV file if you need to. But so this is this I think would be useful for people who have data that's not in the netCDF sort of format. And then once it's in the pandas array, then you can do stuff with that. You can average it and plot it and all that kind of stuff.
Right, do you have any idea how to transform? So there's the word column there.
Which one?
Right there, so you have the Gordon column.
Yeah.
How would you convert that to like separating day, year, month, for example?
Well, there's many options. There's a module in Python called datetime. That would probably be my first stop. Datetime can recognize sort of date-like information. You would probably have to tell it, this is month/day/year or something. But then it would then turn that into something that then you can deal with as a date, or you can even convert that into a number of days since 1900 or whatever you need it to be. I think Pandas has some of that functionality in it also.
Could you show that if you grab that column, what values would it return?
Okay.
Just
Yeah, let's, I gotta get the name of it. Just go down here. Hang on. I have to figure out what the exact syntax is here. So this is just a list of strings, first of all. But if I say like that, that's that string, and I can say import date time, and then date. Okay, I didn't like that. Let's see. I know there's a way to do this. It's just... Typically, I have to look things up in order to get it right, but... Let's see if that works. No. How do you do that? I know there's a way to do that. Basically, this is the procedure. You Google it and you see how... that's it. Come on. Really? strp time. Oh, right. That's what I was doing wrong. And now it doesn't like what I did. Really? Trying to type too fast. Well, almost. Oh, I see. There's a different library that has a different format here. There we go. So now this is an object that specifically knows the year, the month, the day, the hour, and the minute. And then you can do other stuff with that. So, I mean, I guess that was a good example of how relatively easy it is to figure out something in Python, even though it took me a minute. Once I found the information, using it wasn't that bad.
Well, so the rest of us could multiply by a factor of 10.
That factor will decrease as you do it more. All right, I guess we're about out of time. Any last questions?
Thank you very much.
Well, thank you all for coming.